I'd like to take the next couple of minutes to talk about the EUMAEUS project. So EUMAEUS stands for Evaluating Use of Methods for Adverse Events Under Surveillance. I'm one of many collaborators on this project, but it didn't make sense to list everybody because the list keeps growing. So a question that a lot of people might have right now is, how do we know whether a vaccine is safe? And well, of course, we all know that all the vaccines that are being used right now undergo randomized trials. And those trials are typically very good for establishing effectiveness, but maybe not so good for when it comes to establishing safety, especially since these trials are quote unquote limited in sample size, often still having tens of thousands of people. But some of these adverse events that people are interested in are actually like 1 in 100,000, and then you might not actually see a single one of them in your large trial. Also, these trials may not be representative of the actual users. There are lots of people being excluded from these trials that would actually benefit from the vaccine later on. Another way to look at vaccine safety is through use of spontaneous reports. So that's something that's been done is being done quite often. A shortcoming of this approach is that there can be a lot of underreporting, even up to 95% underreporting of adverse events that occur after vaccination. Also, it's not always easy to determine what the denominator is. So you know how many bad things are reported, but you don't know how many people usually were exposed. And also, you need some sort of a background rate, which Shintong's work that she presented just before me actually tries to inform on that question. So a complementary approach that people are considering is to use our observational data. So for example, our insurance claims data um, or our electronic health records. And then you could, if you like, have say a monthly refresh, you could every month evaluate safety of a vaccine. But if we have that data, how do we actually use it to look at the safety? So there are a couple of designs that you could use. One is the historic comparator design, where you can compute the incidence rate somewhere in the past and then see if the rate after vaccination is higher than that historic rate. You could just treat it as a cohort method, where you compare the people that are vaccinated to a sample of people that are not vaccinated and maybe adjust for propensity scores. You can make it fancier with a self-controlled case series design or self-controlled risk interval, where you look at whether the rate of outcomes is higher just after vaccination compared to other time of those same people, or even a case control design where you can ask whether cases are more likely to be recently vaccinated than controls. So several designs are possible, but also once you have a design, there are several ways in which you can declare a signal. One could be well, what if it's I'm just looking for statistical significance? So maybe p smaller than 0.05 is my rule for calling something a signal. But then what if I do multiple testing? If I look at every month and I do that for say 12 months in a row, I'm actually doing a lot of multiple testing. How do I adjust for that? So another approach that's been proposed and often used for these type of studies is called max SPRT, or maximum sequential probability ratio test. So we have a lot of things to choose from. We can choose different methods and we can choose different decision rules for signaling. And basically we want to know which method works best. And that's the question that the EUMAEUS experiment is trying to answer. So we designed an evaluation where we look at historical data of vaccines. So for example, the H1N1 vaccines is one of the vaccines that we're looking at. And we have those data, of course, in our databases. We've defined large set of outcomes that we believe are very unlikely to be caused by those vaccines, which are our negative controls. And we also need some positive controls, but in the past we found you can't really use real positive controls, for one reason being that doctors know about them, so they try to mitigate risks. So you can't actually always see them in your data. So we instead use synthetic positive controls. So these are outcomes that are caused by vaccines, but that's because we artificially boosted the rate of the outcome during the time just after vaccination. And with that setup, we can simply ask the question, well, which method is best at flagging positive controls as being signals, but at the same time, of course, you don't want something that just signals everything. So you also wanted to not signal the negative controls. So the protocol and the package have been finalized. So we also have a repo in OHDSI studies, and we registered the protocol with NCEP. And well, the results are pouring in, but I did want to just not show you no graphs at all. So a little bit of a spoiler here, but I'm not going to go too much into detail here. This is from one of the databases, the CCE database for one of the vaccines. And then over time, so everything on the x-axis here is 1 month. As data accumulates for the various methods you see on the bottom, the specificity, and on the top, the sensitivity. And what you see is for every method, we have some variance, which is denoted by the colors. And so, for example, in this plot for the cohort method, you see that this blue line, the specificity drops pretty quickly. That's because this is the crude one. We're not using any propensity score matching. But that also does mean that you get very high sensitivity. In contrast, the purple one is where we use propensity matching, and we get very good specificity, but that also comes at the price of sensitivity. And so we're now trying to analyze these results. So we're quickly writing all of these papers. The results are coming in, being collected in the database, and can be explored via the Shiny app. And I'm actually running out of time, so I'm not going to go into all of those, but we have 4 papers that are currently being written and led by several people in the OHDSI community. And with that, I'm at the end of my talk.